Hello students, this will lead us through a brief walkthrough of Hess's law. It's very advantageous to know the enthalpy change of our reaction. However, we cannot directly measure heat. We have to indirectly, either through a calorimetry analysis, often through the application of specific heat. We could look at applying information of the enthalpy of formation. Another option is by applying Hess's law. Hess's law is applied when a reaction may be difficult to directly measure, directly analyze. So, there's just a little bit of background. For example, this reaction. Now, of course, we're looking at making hydrogen peroxide. However, this is a great example to teach us Hess's law. Sometimes it's hard for us, maybe available reactants, maybe safety concerns, maybe the energetics. And so, can we be given stepwise little mini reactions that we can manipulate to obtain the overall reaction? So we're actually going to apply some guidelines that we learned in Chapter 4 in balancing oxidation-reduction reactions. All right, what we want to do is obtain this overall reaction by manipulating these mini reactions. I would take the guide of our overall reaction. We need 1 mole of H2 gas. When these little mini reactions, and you will be given the mini reactions, you will not have to come up with these on your own. Here, this reaction involves the reaction of diatomic hydrogen in the gaseous state. However, we have 2 moles, and for my overall reaction, I only need 1. We can change coefficients. We can look at multiplying 1/2 by everything, or dividing all of my coefficients by 2. Now, thermodynamically, whatever I do to all of the coefficients, I also will do to my enthalpy of the reaction. So if I look at 2H2 gas, be very careful of our states, yielding 2H2O liquid, and the enthalpy of this is negative 571.6 kilojoules. If I multiply through by 1/2, I must also adapt this by multiplying by 1/2. So then that would give me H2 gas plus 1/2 O2 gas yields H2O liquid, and my enthalpy, 1/2 of that, would be negative 285.8 kilojoules. All right, this delivers my hydrogen. Okay, next I need 1 mole of oxygen. But this gives me some oxygen, and this also gives me oxygen. So I'm going to wait to look at my oxygen. I need 1 mole of hydrogen peroxide liquid as a product. If I look at this first reaction, I have H2O2 as a reactant, 1 mole. But I need it as a product. You are given permission to flip your reaction. The reaction as written is exothermic. So if I flip it, it'll become endothermic. If the reactant becomes product and vice versa, the sign will flip. So if I flip this, I'm going to have H2O liquid plus 1/2 O2 gas yields H2O2 liquid, and I have a sign change, positive 98 kilojoules. Let's see if I add these reactants and products, if I get my overall reaction. Now remember, if I have like species on the reactant and the product side, those can be reduced or canceled. Hydrogen gas, nothing to cancel. Water liquid, water liquid, that cancels. I have oxygen and oxygen. Oh, and lucky us, 1/2 mole, 1/2 mole, that'll deliver the 1 mole we need. And of course the hydrogen peroxide, thank goodness, does not cancel. So what we have done through manipulation, is obtained our overall reaction, and as I add my mini reactions, I can then add my enthalpy. So the enthalpy of the reaction, which was the goal of all of this, is negative 187.8 kilojoules. If you want to go ahead and try this on your own, and I will reveal my work. If you want to go ahead and give this a try, and then pause, here is the work, and I will review. So the first thing I need is 1 mole of tungsten solid. Well, this first reaction has 2 moles, so I multiply through by 1/2. And being careful if you create new fractions. So multiplying through by 1/2, I also multiply my enthalpy by 1/2. I need carbon in the graphite state. Well, that's what I have here. 1 mole, 1 mole. I don't need to do any changes to that second reaction. I need 1 mole of this tungsten carbide solid. Well, this is the reaction that gives me the tungsten carbide solid, but I need it as a product. So I need to flip my reaction, but I also need to multiply through by 1/2. So I flipped it, multiplied through, my sign will change, and I'm also decreasing it in half. When I add everything up, I have the overall reaction, and my enthalpy is negative 38.0 kilojoules. Just be careful. Do you see 3 halves plus the 2/2? That gives me my 5 halves to cancel. So just be careful with the fractions if you create them. I have another example. Oh. Sorry, this should be delta. So if you want to read through, give it a try. And you should get negative 1789. Best of luck with Hess's law.